Hello learners, welcome to today's lesson. Today we are going to look at the volume of a frustum from 2 mathematics. But before we look at this question, if you have just come across this channel for the first time, kindly subscribe. Going straight to the question, the figure below shows a frustum made by cutting off a small cone on the plane parallel to the base of the original cone. This is where we have the base. The frustum represents a bucket. This is a bucket. You all know how the bucket looks like. The frustum represents a bucket with the open end of diameter 35 centimeters. This is the open end, and if the diameter is 35 centimeters, our radius is going to be equal to 17.5 centimeters. And at the bottom diameter, this is the bottom diameter of 28 centimeters. And in this case, if the diameter is 28, our radius is going to be equal to 14 centimeters. The bucket is 30 centimeters deep. The bucket is 30 centimeters deep. The bucket is used to fill a tank of diameter 2.8 meters and a height of 1.5 meters with water. Determine the number of buckets that must be drawn in order to fill the tank. Anytime you get a question involving the frustum or simply the bucket, just extend it so that we can form what we call a cone, since you cannot get the volume of a frustum directly. Once you form the cone, we are going to get the volume of the entire cone minus the volume of the small cone that we have extended, so that we can remain with the volume of a frustum. In this case, we can call the height of this small cone h. But we know you cannot get the volume of a frustum direct. You must get the volume of the original cone minus the volume of this cone, of the small cone, so that we can remain with that of the frustum now. In this case, how do we get the volume of a cone? Volume of a cone is given by a third pi r squared h. But remember, we do not have the height of the original cone. We do not have also the height of this small cone here. So normally we use similarity and enlargement, because this small cone here is similar to the original cone. So using similarity and enlargement, we say if we take the bigger radius over the smaller radius, this must be able to give us the bigger h over the small h. That is the height of the original cone, and the smaller h represents the height of this smaller cone. Capital R represents the radius of the bigger cone, which is 17.5, over the smaller radius is 14 centimeters, and this must give us the capital H. And to get the capital H, it's from this point to this point here, which is going to be 30 plus the small h, 30 plus the small h over the small h, which is simply h. If we cross multiply here, we are going to have h times 17.5, we get 17.5 h, and this is going to be equal to 14 times 30, you get 420, plus 14 times h, you get 14h. You collect the like terms, 14h is going to move to this other side, so that we have 17.5h minus 14h, and this must give us 420. 17.5h minus 14h will give us 3.5h, and this one is going to be equal to 420. If you want to get the small h now, you can divide both sides by 3.5. Divide by 3.5. This 3.5 and 3.5 goes, so that we get our h as 420 divided by 3.5, that is going to give us 120 centimeters. Once we have our smaller h, we can get the height of the bigger cone, which is 30 plus the smaller h will give us 150 centimeters. Now to get the volume of frustrum, or simply bucket, we are going to get the volume of the bigger cone, and the volume of the bigger cone is going to be equal to 1/3 pi capital R squared capital H, and that represents the volume of the entire cone, then minus the volume of this smaller cone, which is going to be equal to 1/3 pi R squared H. In this case, we are using the small radius for the small cone and the small h for, again, the small cone. We can now replace or substitute the values of h. We are going to have 1/3 times pi is our 22/7 times the capital radius is 17.5 times 17.5, since it is squared, times our capital H, which is 150, and this one here is going to give us the volume of the smaller cone, of the bigger cone, minus 1/3 times 22/7 times our radius squared, and our radius for the smaller cone is 14 centimeters, so it is going to be 14 squared times the height, which is 120, times the height, which is 120. That space is not enough, so we can say minus, we are going to have 1/3 times pi is usually 22/7 times the small radius is 14 times 14 times the small h, which is 120. So this one is going to give us, let us work out the volume of the bigger frustrum by taking 1/3 times 22/7 times 17.5 times 17.5 times 150, and this one is going to give us 48,125 centimeter cubic, minus the volume of the smaller cone, which is 1/3 times 22/7 times 14 times 14 times 120, and this one here is going to give us 24,640, and this one is again centimeter cubic. This is the volume of the bigger cone, and this one is the volume of the smaller cone, and if you take the volume of the bigger cone minus this small cone, it is going to give us the volume of the frustrum, and in this case we take 400, that is 48,125 minus 24,640, and the answer we get is 23,485 centimeter cubic. That is our what? The volume of the frustrum. This frustrum here, or a bucket, is used to fill a tank with a diameter of 2.8 meters and a height of 1.5 meters with water. What we are going to do, we are going to get the volume of the tank, then take the volume of the tank, we divide by the volume of the bucket for us to know the number of buckets required to fill that particular tank. In this case, allow me to remove this part here so that we can get the volume of the tank. So we know volume of tank, The tank is usually in the shape of a cylinder, and to get the volume of a cylinder, we use pi r squared h. And in this case, we know our pi is 22/7 times the radius of the tank. Since the diameter is 2.8 meters, you divide by 2, you get the radius as 1.4 meters. But we can change this one into centimeters because the volume of the bucket is in centimeter cubic. So if you divide this by 2, you get 1.4. Multiply by 100, we are going to have 140 centimeters times 140, and of course times the height. And the height is 1.5. Multiply by 100 to change them into centimeters. This one is going to give us 150. And if you work out this question, you take 22/7, you multiply by 140 times 140 times 150. This one is going to give us 9,240,000 centimeter cubic. This is the volume of the tank. So to get the number of buckets, in this case, we are going to take the volume of the tank, which is 9,240,000. We divide by the volume of the bucket, which is 23,485. And if you take 9,240,000, you divide by 23,485, we are going to get 393.44, which is going to be rounded up to exactly 394 buckets. Since we have 393 full buckets, but we need some water, of course, in order to fill that bucket. So that bucket that we use is going to be rounded up so that we can have exactly 394 buckets, and that is what the question requires us to do. Thank you for watching and welcome to our channel.